Today we're on page 16 of our notes, lesson 5, multiplying polynomials. Polynomials are expressions that are combinations of terms using addition and subtraction that can only have constants and positive integer powers. Well, first off, what are positive integers? Positive integers are 1, 2, 3, 4, 5, and so on. For example, 2x cubed minus 3x squared plus 5 is a polynomial. However, x to the negative 1 plus 2x to the 1/2 plus 1 isn't. It's the negative 1 power here that is not a positive integer, nor the power of 1/2 is not a positive integer. We'll be looking at two methods of multiplying polynomials today. The distributive property, and also what we call an area model. We'll start by multiplying binomials. Recall, how many terms does a binomial have? Yep, you got it. 2 terms. Find the product of 3x squared minus 4 and x squared plus 1 using the distributive property twice. Let's rewrite 3x squared minus 4 times x squared plus 1. Using the distributive property, what we're going to do is we'll take the 3x squared and distribute it. So 3x squared times x squared plus 1. And then we will take our negative 4 and distribute. Negative 4 times x squared plus 1. Okay. So 3x squared times x squared is 3x to the 4th. 3x squared times positive 1 is positive 3x squared. Negative 4, make sure you pick up that sign. Negative 4 times x squared is negative 4x squared. And negative 4 times positive 1 is negative 4. Now we look for like terms. We have two x squared terms. So we combine 3x squared and negative 4x squared is negative x squared. And let's bring down or bring over our 3x to the 4th, minus x squared minus 4. Next, consider the product of 3x plus 2 and 2x plus 5. Find the product using the distributive property. So I'm going to skip the middle step that I did here, all right? Basically, I'm just going to say, okay, I'm taking 3x and timesing it by 2x and positive 5. So 3x times 2x is 6x squared. 3x times positive 5 is positive 15x. And then positive 2 times 2x is positive 4x. And positive 2 times positive 5 is positive 10. Again, look for any like terms to combine. Our x terms here, 15x and 4x is 19x. Let's bring down. So 6x squared plus 19x plus 10. So part A was using distributive property. Part B is we're going to look at what's called an area model, where this is 2 terms and 2 binomials. So you would make a 2 by 2 square. So on the left-hand heading, you would have the binomial 3x plus 2, and the top heading here is our 2x plus 5. And then we would multiply. We would say 3x times 2x is 6x squared, and then 3x times positive 5 is positive 15x. 2 times 2x is 4x, it's in this box, and then 2 times positive 5 is positive 10. And then you look to combine like terms. Now, usually with this area model, your like terms are going to be like diagonally. So here are our like terms. So if we add this diagonal, 4x and positive 15x is positive 19x. And then the other two, so the 6x squared, we were kind of bring down diagonally, so we want to keep our final answer in standard form. And then the plus 10. So here we are. So whatever your preference is when multiplying polynomials, that's fine. I usually tend to use the distributive property. But if you find the area model more helpful to you, then by all means you are welcome to use it. Next, we want to find the product of a binomial and a trinomial. These terms here, terminology rather, or vocabulary. Binomial has 2 terms, it does, and a trinomial has 3 terms, which it does. Using the distributive property or using an area array model. So I will actually work this out both ways, and if you want, you're more than welcome to stop the video and try it on your own. So first, using distributive property, I'm taking 4x plus 3 times 2x squared minus 5x minus 3. So using the distributive property, I'm going to take 4x and times it by 2x squared, which is 8x to the third. And I'm going to take 4x times it by negative 5x, which is negative 20x squared. And then 4x times negative 3 is negative 12x. Next, I'll take the positive 3 and multiply it by 2x squared, which is a positive 6x squared. Positive 3 times negative 5x is a negative 15x. And positive 3 times negative 3 is a negative 9. And then we look for any like terms to combine. Our x squared terms are here. Negative 20 and positive 6 is negative 14x squared. Negative 12x and negative 15x is negative 27x. And let's bring down our 8x cubed and our minus 9 constant. So here we have our final answer, which is a polynomial of 4 terms. And then I'll also show you using the area model. And so whatever model you chose, just check your answer, and then you can, just go through the video to the next problem. Okay, so using the area model, excuse me. All right, so this is 2 by 3. So I want to draw the 2 by 3. There's my 3, so that's going to be my 2x squared minus 5x minus 3 and 4x positive 3. Okay. Now I'm going to do 4x times 2x squared, 8x cubed. 4x times negative 5x, negative 20x squared. 4x times negative 3, negative 12x. Next, positive 3 times 2x squared, 6x squared. Positive 3 times negative 5x, negative 15x. And positive 3 times negative 3, negative 9. Again, look for like terms. We have our x squared terms here. Negative 20 and positive 6 is negative 14x squared. And we have our like x terms here. This is negative 27x. And let's bring down our 8x cubed and our minus 9 at the end. Good, got the same result. And always, if you would kind of get in the habit of putting your polynomials in standard form, right, where the exponents go in descending order, greatest down to least, 3, 2, 1, 0. Okay, it's critical to understand that when polynomials are multiplied, the result is equivalent to the product, and this can be tested with an equivalence test. We have two binomials that we want to find the product of. That's the result from multiplication. And it says to write a trinomial in standard form that is the product of these two binomials. So right now it's telling us our answer should have how many terms? It should have 3 terms. I'm going to use double distribution, but as I said, you're welcome to use the area model if you like. So x times 2x is 2x squared. X times negative 5 is negative 5x. Negative 2 times 2x is negative 4x. Negative 2 times negative 5 is positive 10. And then look to combine any like terms, which we do have. Our x terms are like 2x squared minus 9x plus 10. There's a trinomial, right? 3 terms. It's a trinomial. What is the value of the trinomial when x equals 2? Okay, so we just substitute into our trinomial 2 for every x. So 2 times 2 squared minus 9 times 2 plus 10. 2 squared is 4. 2 times 4 is 8. Minus 9 times 2 is 18 plus 10. 8 minus 18 is negative 10 plus 10 equals 0. So the result is 0. Can you explain why this makes sense based on the two binomials? So if we look back at our two binomials are x minus 2 and 2x minus 5. Well, if we put 2 in for this x, what is 2 minus 2? It's 0. What's 0 times anything? 0 times anything. 0 times anything is 0. Okay, next we want to multiply 3 binomials using our distributive property. So we'll multiply the first 2 binomials, then multiply the result by the third binomial and combine like terms. Okay, so let's take the first 2. I'm taking x minus 2 times x plus 4 using the distributive property. X times x is x squared. X times positive 4 is positive 4x. Negative 2 times x is negative 2x. And negative 2 times positive 4 is negative 8. I'll combine these like terms of negative 2 and positive 4, which is positive 2x. So we've got x squared plus 2x minus 8. So that's our result for multiplying the first 2 binomials. Now we want to take that result and multiply it by our third binomial, x minus 7. So I bring that down. And now using distributive property, I'm taking x squared times x is x cubed. X squared times negative 7x, or excuse me, negative 7 is negative 7x squared. 2x times x is 2x, and 2x times negative 7 is negative 14x. negative 8 times x is negative 8x, and negative 8 times negative 7 is positive 56. And combine like terms. Excuse me, this here should have been the 2x squared. 2x times x is 2x squared. Okay, so combining these like terms, we get a negative 5x squared. And our x terms here are like, that's negative 22x. And let's bring down. So here we have our result in standard form. We've got x cubed minus 5x squared minus 22x plus 56. This is a cubic polynomial because it is degree 3. Cubic is degree 3. Or third degree. For what three values of x will the cubic polynomial that we found in part A have a value of 0? What famous law is this known as? Right. Well, we don't want to look at our cubic end result, but let's go back to our three binomials. And let's say what subtract 2 would result in 0? 2. 2 minus 2 would result in 0. What plus 4 would result in 0? Negative 4. And what subtract 7 would result in 0? 7. So 2, negative 4, and 7 are the three values of x that would result in 0. This is called the zero product law. Because recall, anything times 0 is going to result in 0. Then we're asked to test one of the three values we found in part B, that it is a 0. Test one of the three values we found in part B to verify that it is a 0 for the cubic. So we want to take one of these three and substitute into our cubic polynomial, and the result will be 0. So I'm going to take 2. So 2 cubed minus 5 times 2 squared minus 22 times 2 plus 56. 2 cubed is 8 minus 2 squared is 4. Order of operations here, we do exponents before multiplication. So that's going to be 5 times 4 minus 22 times 2 is 44 plus 56. So we have 8 minus 5 times 4 is 20 minus 44 plus 56. When you are adding and subtracting, the order in which you add or subtract does not matter, so I'm actually going to kind of do this. I'm going to do a negative 20 and a negative 44 is a negative 64, and remember I'm just combining these constants. 8 and positive 56 is positive 64. So we have a negative 64 and a positive 64 does result in 0. So it checks. Again, I want to thank you for your attention.